They also 7.5 deals with analyzing graphs of quadratic functions. Okay, now remember quadratic functions, the graphs are either going to be a U-shaped parabola or it gets flipped over and is upside down, okay? So we're dealing with the parabolas this time, the U-shaped graphs that we get from the x squared graphs, okay? Now, what we're worried about on these graphs, so y'all let me draw us a little graph here. I'm just going to draw a parabola just on the right side. All right, y'all, let me let one in. All right, y'all, so here's our parabola. What we're worried about now on these parabolas is we're worried about these little minimum values, or if it's flipped upside, it would have a maximum value. But we're worried about these points here. This point here is called the vertex. So this vertex gives me either the minimum of the graph or the maximum if it's flipped over, okay? Now, we got a formula to find this vertex on a parabola. All right, y'all, the vertex is going to show up like an ordered pair because we're finding the actual point. So to find that ordered pair, we got a formula. For the x coordinate, we find negative b over 2a. So that gives me the x coordinate. Okay, so to get the x coordinate, we do negative b over 2a. To get the y coordinate, we find f of negative b over 2a. So we get the x value, and we take that x value and plug it back into the function, and that's going to give us our y coordinate. Okay, other things about the vertex we're concerned about. Y'all remember we was doing symmetry with the y-axis? Well, if a parabola is over here, and we draw a vertical line through that vertex, this vertical line cuts this parabola in half. So we call this the axis of symmetry. Or you can call it the line of symmetry. But it's an imaginary dotted line that splits the parabola in half going through the vertex. So an imaginary line that cuts the parabola in half. Now this line comes in the form of an equation. And y'all, we drew these X lines last week, these vertical lines. Vertical lines always had the equation of X equals some number. So if this was coming across the x-axis at 4 here, then my axis of symmetry would be x equals 4, because that's the x value that if we drew an imaginary dotted line would split my parabola in half. Now the third thing this point gives me, it gives me the minimum or maximum value of that function. So remember, these are my y values. So you find the x and then the value for that x. Well, those are the y values. So this gives me the minimum or maximum value. So that means if it's equal to the y values, then the y coordinate of my vertex formula will give me that min or max value. So it is equal to the y value of the vertex. Now remember, these quadratic equations, they're in this form. Ax squared plus bx plus c equals 0. Remember, we've been doing the quadratic formula with these quadratic equations. And remember, they're quadratic because of that x squared. So y'all, here's how to tell if I got a minimum or maximum. I will have a maximum value if a, y'all see this number in front of the x squared here, this a? If this a is positive, I'll have a minimum. If this a is negative, I'll have a max because it flips it over. So I got a maximum value if a is negative, and I'll have a minimum value if a is positive. So if a is negative, your parabola is going to be over like that, and it's going to have a maximum. If the first number is positive, you're going to have a U-shaped parabola, and it'll be a minimum value on that, okay? All righty, so the trick is finding that vertex point. Once we got that vertex, we'll know our axis of symmetry is. It'll be x equals the x value, and we'll know if we got a minimum or maximum value. All right, so let me show you the first example they do. So for number one, they're going to give us a graph here. And let's see, let's go out about 5. All right, so it's not on the negative side. So y'all, it's crossing the x-axis at 2 right here and at 4. Now, my vertex is over here, 1, 2, 3, and down 2. And I'll list this point. This is 3, negative 2. So my graph sort of curves up through like that, and then curves to the left side and up. This is all given, okay? So given the graph, first thing they want to know the vertex. So they want me to find the vertex, axis of symmetry, and the min or max value. So y'all, let's start with our vertex. Well, we got a vertex formula, and the vertex formula is not needed on this one because they're giving me a graph. So I don't have to use my formula for this. I got to look at the graph. Well, y'all, they're giving me the vertex right here. They're telling me that this point is 3, -2. So that is what I got to put in for my vertex. Now, later on, they'll just give us the equation and we'll have to actually find our vertex, okay? But on this one, they gave you the graph. They even labeled that point. So the vertex has to be put in like an ordered pair with parentheses. So my axis of symmetry is blank. Well, the axis of symmetry is an imaginary vertical line going through my vertex. So I got to find the equation of this line. Well, that's going to be x equals, and it's cutting right through the x value of this vertex. So since the x value of this vertex is 3, that means that this line, x equals 3, is cutting my parabola in half. So if they don't give you the x on this one and have x equals, you gotta put x equals 3 as your answer, okay? All right, so that's my line of symmetry. Then it asks me for the min or max value. Now, they don't want me to tell them if it's a minimum or maximum, but looking at this, since that's a U shape with a valley, this is a minimum value for sure. Okay, it's a minimum if it looks like a U. If it's flipped over and you got a mountaintop, it's a max, okay? So valleys are minimums. And we said that the min or max value was equal to the y value of that parabola. We all are giving us the y value, and that is -2. So you put -2 in the answer blank and be done. Okay, so that's what we're going to find by hand given the equations. They just want you to look at the graph and be able to realize that that's your vertex. It's a minimum value. And if you cut a line through that x value, it will split that parabola in half. Now, we'll say these will want us to graph them. So, y'all, I'm just going to show you. You're going to have to find the vertex anyway. But once we find the vertex, to get my other 2 points, I'm just going to use the calculator. Okay? So this one says find the vertex, axis of symmetry, determine if min or max value, and find that value. And then finally, graph. Now the graph is tricky on this one. When you're graphing, you got to plot the vertex first. So in section 2.1 and 2.2, when we graphed parabolas, it didn't matter what 3 points we put in or what order. In this section, since we're using the vertex formula, you got to plot that vertex first. All right, y'all, so the equation they're giving me on this one, f of x equals x squared minus 8x plus 7. All right, so I got to find A, B, and C real quick. And A, B, and C are just like they were on the quadratic formula. It's the numbers in front of the variables here. So that would be a 1 for the A, -8 for B, and then 7 for my C. So the first thing they wanted was my vertex. And the vertex formula was -b over 2a, f of -b over 2a. So for the vertex, I got to get the x coordinate first. So to get the x, we're going to do -b over 2a. So that's just plugging our numbers in for our variables here. So we got that negative, so write the negative. And then b is going in parentheses because it's a -8. So just like on the quad formula, the negative is always in the formula. And if you got a negative number, you're going to have two negatives there. On the bottom is 2 times my 1. All right, so negative times -8 makes that a +8. 2 times 1 is 2. And 8 divided by 2 gives me 4. So I know the x coordinate is going to be a 4. So here's my vertex. X will be 4. So now we got to get the y value. So to get the y value, we're finding f of what did -b over 2a give us? Well, that gave us 4. So since the x value is 4, to get the y value, we find f of 4. So you take your function here and put a 4 in for both of these x's. So you're going to have 4 squared minus 8 times 4 plus 7. So y'all, if you was to work this out, 4 squared would be 16 minus 8 times 4 is 32, and then plus my 7. So exponents, and then I multiplied to 8 and 4. All right, so 16 minus 32 is a -16. And a -16 plus that 7 gives me a answer of -9. So my x value is 4. My y value is -9. Okay, y'all, that's the trick of the vertex formula. You find what the x value is by doing -b over 2a. Once you got that x value, you plug it back into the function to get the y value, okay? So if I was going to write out what I just did here, to get the vertex, we found the x value by using -b over 2a. That was the first step I did up here, getting the x. Then we plugged that value into the function to get the y value. Okay, so I plugged it in, got my x, took that number, plugged it into my actual function, and got my y value. So y'all, that's what I did on the vertex. Next, the axis of symmetry. Well, remember the axis of symmetry is going to be x equals the x value of the vertex. So once we got the vertex, we know the x value is 4. So that means the line of symmetry will be x equals 4. Now y'all remember here, this A is positive up here. So remember, since this A is positive, my graph is going to look like a U. Remember, we said if the A was positive, we would have a minimum, okay? So what's happening at this x value of 4, that line is cutting my parabola in half. All righty, so it says min or max value. So first of all, do I got a minimum or maximum? Well, A is positive, which gave me a minimum. So we got a minimum, and y'all, that value is equal to the y value of the vertex. So that value would be -9. So you don't put y equals or nothing on this. This ain't a line. This is the actual minimum y value. This one was a line. That's why we had to put x equals that 4 on it, okay? And then this was my vertex. So I had to list it as an ordered pair. Now, here's the thing. When you graph this, you're going to need 3 points. Because you're going to choose the 3-point x squared tool. You're going to choose that tool. You're going to plot the vertex first. Well, my vertex was that 4, -9. Once you plot your vertex, then you can pick 2 more points. Now you can actually solve this by setting it equal to 0, and you'll know where it's crossing the x-intercept at. If you want to do it that way, you can find those zeros. But y'all, on this one, I'll show you what I would do on my calculator to get my other 2 points, okay? But we do got to plot that 4, -9 first. Now, to get my other points, I'm just going to go to my calculator. I'm going to go to y equals, and I'm going to plot that function. I had an x squared. I had minus 8x. I had plus 7. So there's my function. Now, if you want to see what it's going to look like when you're done graphing it in MATLAB, it's going to be a U shape. And y'all look at that. It's crossing the x-axis at 1. And then over here at 8. Or 7, it looks like, right? 1 and 7. But watch this. When you go to second table, let me head over there towards that 1 and 7, get over in that area. All right, so there's 1. Look at that y value, 0. That means that's the x-intercept. 7, 0. That's an x-intercept. And y'all look right here. In the middle is my 4, -9. So since 4, -9 was my vertex, I can pick any other 2 points. So y'all, I would probably pick that 1, 0. That one up here, that 1, 0 looks easy to plot up here. So I would probably pick 1, 0, and then I would probably pick 7, 0 as my other point. So you just got to get 2 other points off your table and then plot that graph. And y'all, like I said, you've got to choose the 3-point tool, plot the vertex first, and then any of those 2 points you pick, okay? All right, y'all. So my next one is similar to that one. We're going to find the vertex. Axis of symmetry. Um, min or max and value. And then graph. All right, this time they're giving me f of x equals negative x squared minus 10x minus 27. All righty, so the first thing, let's get that vertex. Now, y'all, let me show you this one. Remember, let's get our A. A is a -1. B is a -10. C is a -27. But what I do know on this, since this A is negative, remember, if the A is negative, that flips your graph upside down. So since A is negative, I'm going to get a maximum value this time, okay? All right, y'all, so let's get the X value. That's going to be negative B over 2A. So that's going to equal a negative times -10 over 2 times -1. All right, y'all, so the two negatives on top, negative times negative, makes that a positive 10. But on bottom, you got 2 times -1, which is -2. And then 10 divided by -2 gives us a -5. So we know the X value of the vertex is -5. So now we're going to get our Y value. Well, remember, the Y value equals F of that -5. So we're going to put a -5 in for the X. Now, y'all watch this. Here's where I get people. You're plugging -5 in for this X right here. But this negative is here already. So the first thing you do is write down that negative. Then you put your -5 in parentheses and square that. Then you got -10 times that -5. And then that's minus that 27. Now, y'all, here's where I get most people in trouble. I see two negatives here, but this does not make this a positive. You can't multiply these two negatives before you do that exponent. So the exponent gets done first. So this negative right here, you bring that negative down. That negative that was out here gets multiplied by what we get when we multiply -5 times -5. Well, that -5 times -5 is going to make that a positive 25. Now I'm just going to bring everything else down. So I wanted y'all to see on that step, the only thing I did was that exponent. Now I got that negative out front, but it's not getting multiplied by a negative number now. So that negative times that 25 makes that a -25. Minus 10 times -5 makes that a positive 50. And then minus 27. All right, y'all, so let's see what we get. -25 plus 50 is 25. So that gives you 25 minus 27, which will give us a -2. So our y value is -2. All right, so we got everything we need now. That's my vertex. My axis of symmetry is going to be x equals the x value of the vertex, which is -5. All right, it says a min or max. Well, we said we had a maximum, y'all. We got a maximum because this A was negative. And remember, those negatives reflect those graphs over. So that's why it makes it a maximum. So you got a maximum, and the y value would be the y value, which is -2. And y'all, that's the trick to these. You find this vertex, and then you got your line of symmetry, and you got your min or max value. Now, when you graph this, you're going to choose the 3-point quadratic tool. You're going to plot -5, -2, then plot 2 more points. And remember, to get to 2 more points, I graphed on calculator. Okay. All righty, y'all. These next couple of questions are true or false. And it sort of goes back to the 7-2 stuff I was doing when I was moving my graphs around, okay? So the function f of x equals 4x squared minus 3x minus 8 has a maximum value. So let's see if that's true or false. The function, they're giving me a function, and they're saying it has a maximum value. Well, remember, the min or max values were determined by the A, which is that 4. So for this one, A is 4. This is positive. So we said if the 4 was positive, it would have a minimum. So since 4 is positive, so it would be a minimum. But look what they're saying. They're saying it has a maximum value. Well, that don't have a maximum value. We just said if the 4 was positive, it had a minimum. So this would be a false. Okay. This actually has a minimum, not a maximum. All right, let's try another one. All right, y'all know the true or false. So what am I on, like number 5, I think? True or false? The graph of h of x equals x plus 3 squared can be obtained by translating the graph h of x equals x squared left 3 units. So this goes back to the vertical, horizontal moves we did, the transformations. So what we got to do is figure out what happens when you add 3 to the variable inside the parentheses. Well, that's going to make it go left or right. Remember, if the number's inside parentheses with the variable, that makes you go left or right. And we said when you added to the variable, it would move you left. So left, since 3 is being added. All right, well, they said, hey, it would move it left 3 units. So since that actually does make it go left 3 units, this one would be a true. All right, now, so these ones, they start sort of turning it up a little bit. So for these ones, we're going to find the vertex, which we've been doing. So nothing new there. We're going to determine min or max and the value. But y'all, here's the new one. We're going to find the range. So the range is a new one. That's dealing with the y values. Oh, and watch this. Determine intervals of increasing and decreasing. And we don't have to graph these. Now let me tell you this. These the range is going to deal with the y values. The increasing and decreasing, they deal with the x values. So increasing is going to deal with x values, and it's where the graph goes uphill left to right for increasing. Decreasing will be looking at the x values where the graph goes downhill left to right. So you always read the graphs left to right. Uphill if it's going uphill to the right, downhill if the graph goes down left to right. We're dealing with parabolas, right? And these parabolas, if you look at it on a parabola, one side goes down, one side's going to go up. Okay. So when we find a vertex, we'll be finding what side comes down and the interval on the right side where it's going up. And then the range is going to be the y values. So like the smallest y value upward. So the range is the y values starting at the lowest y value and going up. So those two we're about to tackle when we hit those. So for this function, we got f of x squared minus 6x plus 5. All right, y'all. So A is 1, B is -6, and C is 5. So since this A is positive no matter what, my parabola is going to go downhill and then uphill. But that vertex will be a minimum. That'll be a minimum because A is positive. So we got to find this minimum point, and that'll answer almost all these questions. So y'all, let's get our vertex. The x equals -b over 2a. That'll be a negative times -6 over 2 times my a, which is 1. All right, y'all, so double negatives make that a +6. 2 times 1 is 2. And then 6 divided by 2 gives me a 3. So for my vertex, at the moment, I know the x value is a 3. So I now know that this axis of symmetry here is equal to the x equals 3. But they're not even asking for that. But y'all, I'm just drawing that so that you can see what's happening on this. So that's my x value. Let's get the y value. The y value is going to equal f of 3. So f of 3 will equal 3 squared minus 6 times 3 plus 5. All right, y'all. 3 squared is 9. Minus 6 times 3 is 18. Plus 5. So if you notice, 9 minus 18 is negative 9. Negative 9 plus 5 is a negative 4. So my vertex has a y value of negative 4. So this point right here is 3, negative 4. Which means if I was to draw my horizontal line here, this would be at negative 4 because that's the minimum y value on this, okay? So we got our vertex. Min or max and the value. Well, we got a valley, so we got a minimum. And it's a minimum because that A is positive. So we got a minimum. And the value is equal to the y value of negative 4. So remember, that is the minimum y value of this parabola. All right, the range. Y'all, this is new for this section. So since we got a minimum y value of negative 4, the minimum y value of negative 4 will be in the bracket and a negative 4. You use brackets around numbers on the range, okay? Because brackets means it includes that number. Now, y'all, watch this. If this is the minimum y value and the y values are headed upwards, this graph goes on forever upward. Well, on the y values, if you're heading upward, we say you're headed towards positive infinity. Now, infinity always has curves, just like we used on our interval notation last week. So y'all, the range on this one, the smallest y value was negative 4, and then it went towards, when you're headed up that way on the x, on the y's, it's headed towards positive infinity. All righty. Intervals of increasing. So increasing is the part of my graph going uphill. Well, y'all look at this. This left side is going downhill. This side is going downhill. The right side is going uphill. So since this side of the graph is going uphill, this side of the graph is increasing. But when I look for intervals of increasing, I'm looking at what x value did it start increasing at, and then what's that headed towards. So this graph starts increasing at that vertex, which has an x value of 3. So the increasing is going to start at 3. So let's say it starts here, starts at 3. Now y'all look at this. This graph is increasing to the right, and it's increasing forever. So as my x's head out towards the right, that graph is going uphill. And y'all, if I keep headed toward the right, I'm headed towards positive infinity. All right, so one side will head towards infinity. Well, what about this side that's decreasing? I know where the x value is where it stops decreasing. Because see, as I come in from the left, this graph is decreasing until I get to that x value of 3. So I know where that one ends. That one ends at that 3 on my x. So I know where it ends. But where does it start over here? What do we say we're starting at if we're over here on the left side and we're starting out here and we're coming in? Y'all, we say we're starting at negative infinity. Although this graph looks like it's going uphill to the left, we really got to read them left to right. And it's coming in from the left like this, going downhill. So my x's are way out here at negative infinity until I get to the x value 3. It stops going downhill and then it starts going uphill. Okay, so that's what they're doing on that one and this one coming up. So y'all, f of x equals negative 4x squared minus 20x plus 9. Whoops, let me pull my line up. All right, so let's get our A, which is negative 4. B is the negative 20. And C is 9. So what do we know about this graph? What's it going to look like? Well, this A is negative. Since A is negative, that's going to flip my parabola over. And I'm going to have a maximum value due to that negative, okay? All right, so first we want our vertex. I'm going to get the x value by doing negative b over 2a. So that'll be negative times negative 20 over 2 times negative 4. Well, now look at this one. Negative and negative make that a positive 20. Uh-oh, y'all, but 2 times negative 4 gives me a negative 8. So I can't divide that, but I got to reduce it. So it will be a negative, let's see, 20 and 8, they both can be divided by 4. They can be divided by 2, but 4 would be the biggest number. So 20 divided by 4 will make that a 5. 8 divided by 4 makes that a 2. So this time my vertex is going to be a negative 5 halves for the x. So remember, if I'm cruising along that x-axis, this vertex is at negative 5 halves now on the x-axis. All right, so now we got to get the y value. We're going to find f of negative 5 halves. That'll equal negative 4 times negative 5 halves squared minus 20 times negative 5 halves plus 9. So, if you don't like fractions, you can plug this right into your calculator, okay? And it would give you the answer. I'm actually going to work it by hand. First thing you would do is the fraction raised to an exponent. So you would multiply the top, negative 5 times negative 5, make that a 25. And then you square the bottom also. 2 times 2 is 4. All right, y'all. So here we go. -4 will divide by that 4 right there. That -4 will divide by that 4, making that a -1. -1 times 25 is -25. This -20 will divide by 2, making that a -10. -10 times -5 is a +50. And then at the end is +9. So let's see, -25 and 50 is 25, plus 9 is 34. So if you'd have plugged it into the calculator right here, you would have got 34 out of that. So that means 34 is the tallest Y value. Okay? 34 is the maximum Y value. All right, so my vertex, -5/2, 34. My min or max, we all min or max. We said we got a maximum because that A was negative. So we got a maximum on this one. And then the maximum Y value we said was 34. Now the range. Remember, the range always starts from the bottom and goes up. But y'all look here. On my range, the maximum range value was 34. So it's going to end with that 34. Notice the minimum started with the number and went up. Well, when it's the maximum Y value, that's the ending point. So where are these values coming from? Well, for the Y's, we say they're coming from -infinity. So the Y values are -infinity down here. And if they're headed upward, 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 they're headed towards positive, okay? All right, y'all, what was next? Increasing. Well, this graph is going uphill on the left side. That's going uphill left to right if you come in from the left side. Now, I know where it stops at. It stops at that -5/2. Because remember, these go by the X's, the range went by the Y. Oh, y'all, we didn't close our parentheses, so make sure we close our parentheses. All right, so if it's coming in from the left, headed towards that -5/2, this one is starting at -infinity. So it starts out here at -infinity, and then it ends at -5/2. So remember, this is the start and end again. So how about the decreasing? Decreasing, where do you start going downhill? When do you end going downhill? Well, on the right side of this graph is going downhill here. So since the right side's going downhill, it started at the X value of -5/2 here. And then as these X's were headed toward the right, these X's are headed towards positive infinity. Okay, so that's what you got to remember on your X and Y axis. -infinity is over here and positive. On the Y, -infinity is down here and positive infinity is up here, okay?
So why wouldn't that be it's headed toward negative infinity?
Which one? This one?
Yes, because it's going down.
Well, Aaron, think about this though. What's going down is the Y values, right?
Hmm.
The Y values are going down. But remember, the decreasing and increasing intervals are looking at the X values. So watch this. So although this point went down, it had an X value right here. Although this point's going down, we're looking at this X value right here, right?
Okay.
Although these Y values are definitely going down, but my X values aren't, they're still going out toward the
Okay.
right. Okay. So, and that's the trick on those is just realize, hey, we're looking at the X values and not the range values, which were the Y's. All right, y'all. So the last one was just an application problem. Um, and I'll show you what the problem it says. A toy rocket is shot vertically into the air from a launching pad. Let me with a velocity, blah, blah, blah. We don't care about all that. What we care about is this equation right here. So let me write this down. It's h of t equals negative 16t squared plus 64t plus 3. So this gives the height of the rocket using time as the variable. Okay, so this is the height of the rocket based on the time. Well, that makes sense because the rocket, when you shoot it, as it goes further in time, the rocket's going to go up to a maximum height and then it's going to start falling back down. So a rocket, if you let the x-axis be time, and if you let the y-axis be the height, right? So when you start at time equals 0, you shoot the rocket, it's going to go up, it's going to reach a maximum height, and then it's going to come back down. So what we're looking at is that maximum height right there. So y'all with me? A lot of times now in the real world, we don't have to draw the whole X and Y axis, right? All we need is this little corner. So this is like the positive section of the X and Y system. Now, I'll tell you what these came from. The negative 16t squared, when you see a negative number, that's your gravity. So gravity is going to want to pull it down. That's why that's negative. This 64t, well, they said it had an initial velocity of 64. So this would be what they get from the speed of the rocket. So the speed of the rocket is going to want to make it go up. Now the 3 they got at the end, because the launching pad was 3 feet above the ground. So its starting height, when there was no time, would be to 3 feet. So the 3 was the starting height. And y'all, you don't have to know all that. I'm just like to show y'all what the stuff means in the formula. If you ever have a physics class or something like that, that's where these are coming from. So the negative gravity wants to pull it down, the speed wants to push it up, and it's starting at 3 feet. So what they want to know is um, the rocket reaches maximum height um, at blank seconds after launch. And then the maximum height is blank. Now remember, since my A is negative 16, look at this. It was a negative 16. That's why we knew we had a maximum on this one, okay? All righty, so what we're really looking for first is this T, which is our time. Once we get that, we'll look and see what our height is. So remember, if you're doing the vertex formula, T would be like your X value. So the X value would be the time. The Y value we get will be the height. Because remember, the function is the height. So y'all, let's get our time. the time equals negative b over 2a. So that's going to equal a negative b, which is 64. Right, I'm getting b from my formula, 64 over 2 times a, which is a negative 16. So y'all, let's see what I get. Negative 64. 2 times negative 16 is negative 32. And look at that. Time has to be positive when I'm done. And a negative of a negative makes this a positive. Looks like I'm getting a 2 on mine. So I know that the maximum height was reached 2 seconds after launch. So y'all, that rocket went quick. 1001, 1002. It's already at maximum height. So what is the maximum height? That means we got to find h of 2. So that'll equal negative 16 times 2 squared plus 64 times 2 plus 3. Now this one, it will let you do this one as a decimal. All right, y'all, so let's see what we get here. So negative 16 times 2 squared plus 64 times 2 plus 3. All right, y'all, let's hit enter. Whoops. Let's hit enter. And I get 67. So that means my little rocket took 2 seconds to get a maximum height here of 67 feet. And then it started coming back down. So you see what's happening? It reaches its maximum height, and then the heights are starting to get lower and lower. Okay? So it went uphill till it got to that x value. And then at that x value, headed towards infinity, it went downhill. All right, y'all. So that is 7.5 analyzing graphs. So the next sections are pretty small, but we'll hit them after break, okay? So y'all, I'm showing 11:04. So we'll do our break till 11:14, okay? And y'all, I'll see y'all at 11:14. Monica, I just seen your email, so happy, good job getting on, I guess.
I got a question. So
Mhm.
on the assignments that are under support, do we have to do those or are they just for help?
There have to be done. They only count in toward the homework grade.
But they do have to be done. Okay, I
Yeah.
just want to
And they're usually pretty small though.
okay. Yeah.
All right, y'all, so we got two sections. These are two short sections. So let me get us going again and we'll knock out 6.1. Let me see what my chat's saying. Um, oh yeah, I seen a video yesterday. Y'all should have got a video in your email yesterday. I'm showing it sent. Um, but I'll send that one again today too then, okay? All right, y'all, 6.1 deals with radical expressions. And we're just going to look at finding the domain of a radical expression. And then show you how to graph them on the calculator. So the thing about these, taking the square root of a, this gives a real number. If the a is greater than or equal to 0. The smallest number I can take the square root of is a 0, okay? Square root of 0 is 0. Square root of 1 is 1. So any positive number greater than 0, I can take the square root of and get a real number. But remember, if you put a negative under the radical and try to take the square root of a negative number, then you get imaginary results, all the I stuff. So when we do a domain, domains must include all x values for which the y values equal a real number. Well, taking square roots of negative numbers is not a real number. Those were imaginary. So that's why on our domains, on a domain of a radical, we said, now, what we call this under the radical, we call that the radicand. So the radicand is what's under the radical. So the first thing you do, you're going to set the radicand greater than or equal to 0. You're going to solve for the variable. And then write the domain. All righty, so these first two examples are just like the one I'm about to show you. So I'm going to do one of these. This one says determine the domain of the function. They're giving me f of x equals square root of 2x plus 1. So all of this under the radical, that is what we call the radicand. And it's all under that radical. So since it's all under the radical, my first step is to set that greater than or equal to 0. Now, solve for the variable. So now we're going to solve for x. So y'all, we're going to move to 1 by subtracting it first. So 2x, those cancel, so that's greater than or equal to -1. Now, divide both sides by 2. Now, here's one thing you got to remember. Since you got this greater than and less than stuff going on, if you divide by negative here, remember, if I'd have divided by negative, I would have had to turn that around, okay? All right, y'all, so let's see. 2 divided by 2 gives me 1x greater than or equal, and y'all, I can't do nothing to that, so that's going to stay -1/2. So on that one, we would choose x such that x is greater than or equal to a -1/2. And these ones were actually multiple choice. Actually, everything on this homework assignment was multiple choice. But yeah, choose the one that's got the greater than or equal to -1/2 and be done. So the second thing in the world that we were worried about on domains are the radicals, and they got to be greater than or equal to 0. The other thing was the fractions, remember. On fractions, we couldn't have zeros in the denominator. Now, y'all, on the next few exercises, they want us to graph f of x equals -2 square root of x. So the trick on these is just to show you how to graph them so you can pick one of their 4 pictures. So y'all, let's go to y equals and graph this. So go to y equals, I'm going to clear everything out. All right, so I had -2, so hit the -2. Square root is the blue second button, and then the x squared button. And then I just put in my 2x, my x. Where's my x? Right there. And then put in my x. So now I got -2 square root of x. Y'all, when I hit graph, I'll be able to get one of my 4 pictures. So look, it's now going sort of downhill, starting at the origin of the graph. And y'all, that's a trick on those. They'll have 4 pictures and you'll pick the one that went sort of downhill to the right, starting at that origin. And y'all, that's all 6-1 is. Do a domain problem, 2 of them that are just like this one, and then you got like 3 graphs to pick pictures out of, okay? All right, so okay, so 6-8 deals with piecewise functions. And then the increasing and decreasing stuff. All right, so let me describe. We'll start out with using the piecewise functions. And we'll see if y'all have ever used one. And I'll guarantee you, most of y'all have done a piecewise function in the real world. But a piecewise function is a set of functions, in which the domain determines which function is used to evaluate that value given. So it's a set of functions, and we look at the domain to determine which function is used to evaluate that value. Now, y'all might say, well, I've never used a piecewise function, but I guarantee you have. Have y'all ever worked a job paid by the hour? Y'all work for hourly pay in your lifetime? Have y'all ever been given overtime pay?
Yeah.
So let me say this. So when you work that job by the hour, anything you work from 0 hours up to 40 hours, they pretty much multiplied your time by your money, right? And they gave you your paycheck. But when you worked overtime, anything that you worked over that 40 hours, most places give you what they call time and a half. So you're using a different equation now to evaluate your pay than you did when you worked 40 hours or less. So that's an example of a piecewise function in the real world. You know, the whatever time is, whatever that value is, if I work 45 hours, well, I would use the equation where I had the time and a half from overtime. If I work 30 hours, then I'm going to use the equation that takes my hours times my pay. So y'all, that's what this section's about when you see a piecewise function. So what they're doing on these examples. So given the piecewise function, determine which expression would be used to find f of a -9. All right, so here's my piecewise function. Remember, it's going to be a set of equations. They got 3x and then a comma. So we use 3 times x for any x's that are less than -5. So if the x values are -6, -7, -8, anything going towards negative infinity, if they're less than -5, I use 3 times x. I use x squared for -3, whoops, -5, my bad, y'all. -5 less than or equal to x, which is less than 2. And then I use 8 times x for any x that is greater than or equal to 2. So y'all up here, you use this equation if your numbers are less than -5. So that would be any number like -6, -7, -8, and so on. Anything less than -5. If it equals -5, then you use the second equation, because this one says -5 can equal x, but it's going to be less than 2. So this one would include numbers like -5, -4, -3, and 1. But it don't include 2, because there's not an equals on that. So this one says for any x greater than or equal to 2. Well, that'll be 2, 3, 4, 5, blah, 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 blah. Anything bigger than or equal to 2, you use this equation. So y'all look here. They want me to know which equation would I use to find f of -9. Well, f of negative 9, is that less than negative 5? Well, there's negative 6, negative 7, negative 8. Next would be negative 9, then negative 10, on out towards negative infinity. All these are less than negative 5. So since negative 9 is less than negative 5, we would use the 3x equation. Now, they don't want me to plug it in and find the value. They just wanted to know which equation would you use. So y'all, guess what? You got 2 doing that. You're just going to find the value. Where does your value lie in the domain? This is all your domain stuff. Once you know what domain you're in, then you pick out which equation you have, okay? All right, y'all, so we're going to have to draw a graph real quick for this next example. All right, y'all, so I'm going to go out about 7, I guess. All right, so now over here at 4, negative 1, I got a point, and then I got a point over here at negative 4, negative 1. So this graph connects straight across, and then it goes now, these arrows don't mean direction on this. This just means the graph goes on forever in both directions. Okay? Now, this one wants us to find the increasing, decreasing, and constant. So really, like we did on the last section while ago, except now we got a new one called constant. Now remember, you read the graphs left to right. And we're only concerned with x values. When we're looking at increasing, decreasing, and constant, it's only the x values that it's happening, not the y values, okay? So the x value right here, this x value right here is negative 4. This x value right here is at a positive 4. So those are the x values where my graph changes, and then it changes over here. Now, this part of the graph, reading left to right, this part of the graph is going downhill. So that means this section is decreasing because it's going downhill left to right. This part where it stays like a horizontal line, this part is constant. This last part is going uphill. So that's where my graph is increasing. Now, I'm only looking for the x values. So increasing. Well, right here's the x value it started increasing at. It increased at 4. And y'all, these always have curvy parentheses, okay? So at this x value of 4, my graph starts increasing as I head towards the right, which is heading towards positive infinity. Now, this side over here is decreasing. Now, This graph goes on forever over here, remember? So it's starting way out here at negative infinity, and my graph is going downhill as I come in and get to that x value, which was -4. So you're decreasing from negative infinity to that -4. So remember, we're only looking at the x's on this, okay? And we're going left to right on them. So now they say constant. At what x value did it start going straight across? Well, it started at this x value, which was -4. Okay. And as I cruise along these x-axis, that line is staying constant until I get to this x value, which was +4. So look, all your intervals are going to connect together. It starts at negative infinity and it's decreased until it got to -4. At -4, it started being constant until it got to +4. And then from that +4, it started increasing as my x's went out towards infinity. So just remember on those, they're only wanting x values, okay? I didn't care that that was at -1 on the y's, okay? Just wanted to know the intervals where it was doing the increasing and decreasing. All righty, y'all, watch this one. New terminology for you. Determine any relative maxima or minima and intervals of increasing and decreasing. And really, there's a few of these. So this one starts out like and we're just going to write the main points of this. This one is showing me a parabola over here. And both these are going down. Now, they're giving me this point right here, though. They're telling me that this point is -4.5 and 8.25. So they're giving me the point. So is it a maximum or minimum? That's fancy words for, is that a maximum or minimum point? Well, that's a maxima because it is a peak. Remember, the maximas are peaks, the minimums are valley. So it is a maxima because it's a peak. And then it says the maximum occurs at x equals blank and has a value blank. Well, the x value it's happening, they're giving me the x. The x value is -4.5. And the maximum, remember, is always the vertex, and they gave us that. And then the value is equal to the y value, which is 8.25. So notice, they're giving us everything on these problems, okay? All right, then it wants increasing. All right, so increasing is the part of my graph going uphill, left to right. So that's this left side is increasing. So it's increasing as my x's come in from the left and they get to this point right here. So they're coming in from negative infinity. So anytime your graph is upside down like mine, the increasing will be the first part of it, and it starts at negative infinity and goes to the x value, which is negative 4.5. So where is it decreasing? Well, decreasing is the part of my graph going downhill. And it starts at this point, which was my negative 4.5, as my x's head towards positive infinity. You know, that's a trick on it. As long as you remember to stay on the x's for that interval stuff, you're good to go. All right, so let me do one more of these and then we'll do an actual piecewise function where they give us a number, okay? So we're going to still determine any maximum or minimums, intervals of increase and decreasing, but y'all look at this one. Now I'm just going to put the main points on here. So over here, I got a point at -2, -1. And then over here, I got a point at 4, -6. All right, so this one comes out like this. This one's coming in from like that. And then they sort of hook. This one comes down and gets into that one. All right, but I got 2 points on here. So this point is a peak or a mountaintop. So this point is a max. This point in this little section, this is the valley. So this would be what we call a relative minimum. So this one only had one, but this graph has two. It's got a peak and a valley. Okay, so these are what we call like a relative maximum and a relative minimum. So the first thing they go is relative maximum is blank at x equals blank. Then it says relative minimum is blank at x equals blank. So they want the maximum first. That's this little part. Now I know the x value is -2. So where it says x equals, for the x equals, I'm putting in my -2. And then the maximum value was the -1. So be careful. Notice up here, MATLAB wanted the x first and then the y value. On this one, it wants the value, then the x. All right, here's my minimum. So it happened that the x equals 4. So at x equals 4, the minimum value was a -6. All right, y'all, then we had increasing and decreasing. Well, look here. This first little section right here, this is increasing. This section's going downhill is decreasing. But y'all look at this. This last section is increasing. So if you got 2 points of interest that means you got more than one interval on some of these. So let's see, where's this one increasing? Here's the x value. Well, the first one ends at -2 for the increasing. So I know that ends at -2. So where's it starting at? It's starting at -infinity until it gets to -2. And it's increasing on this section. Now I know where this one starts increasing at this one. I know this one starts at that 4. Because 4 is the x value right here. So at this x value, my graph starts going up, up, up as my x's head towards positive infinity. So it goes from 4 to infinity. Notice how I'm only focusing on the x values. So then it's decreasing with this little section. So where does that one start? Where does it end? Well, this one starts going downhill at this x value of -2. And then the graph is going downhill, 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 till I get to this x value, which was 4. So y'all, once again, all these will connect together. -infinity to -2. -2 to 4. 4 to infinity. Okay? So if you got two different parts going uphill, you'll have two intervals. All right, y'all. So I said the last one was going to be a piecewise function. But this time, they want us to actually find those values, okay? So for the piecewise function, find g of -4, g of a +4, and g of 7. So it's going to be 3 problems in one, basically. Now here's our piecewise function. G of x equals, and y'all, I got 2 equations. X plus 5 for any x's less than or equal to 4. It equals 7 minus x for any x's greater than 4. So I got to find these 3 values, and here's my 2 domains. So it looks like the first one, any number less than or equal to 4, I'm going to use that equations. So the biggest number is 4, but it can be 4 because it equals. So 4, 3, 2, 1, 0, -1, -2, blah, 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 blah. As far as I can go, negative will be less than 4. But the largest number you can use on that one is 4. On this one, it says x has to be greater than 4. So that means 5 would be the smallest number you could use for the second equation. Numbers like 5, 6, 7, 8, 9, 10, blah, 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 blah. Anything bigger than 4 uses this equation. Anything less than or equal to 4 uses the first equation. So I got a g of -4. Is -4 less than 4 and equal, or is it greater? Well, it's less than 4. So remember, we said any number negative is less than a positive. So you got to use this equation. So that means take that equation and put a -4 in for that x. So you're using the x plus 5 equation. Now you're putting a -4 in for the x, and -4 plus 5 equals 1. So g of -4 equals 1. They want g of 4 next. So that 4 is either going to be less than or equal to 4, or it's going to be greater than 4. Well, y'all, 4 is equal to 4. So since we got the equals on this 4, we got to use that equation. Because we said the biggest number we could use here was that 4, okay? So since 4 is a 4, we're going to use this equation again, the x plus 5. All right, we're putting a 4 in for the x this time. And y'all, 4 plus 5 gives me a 9. So -4, I use this one because that's less than 4. +4, I use this one because it was equal to 4. Now I got a g of 7. Well, 7 is not less than 4. So I can't use the first equation because the biggest number I could use there was 4. Well, let's look at this second equation. It says if my x is greater than 4. And we said numbers that were greater were like 5, 6, 7, 8, 9, 10, 11, 12, blah, 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 all the way to infinity. So 7 is greater than 4. We're going to use this equation, which is 7 minus x. All right, I got to put a 7 in for that x. So I'm going to get 7 minus 7. And y'all, 7 minus 7 gives us a big 0. So y'all remember the first 2 problems or so, you just had to pick the equations out. But on the very last problem, they actually wanted you to find function values using the piecewise function, okay? And then remember, on the increasing and decreasing stuff, we were only looking at x values, okay? All right, y'all, so Monday will be a little more mellow. I'm only going to do the one section we got left, which is 5.4. So